Right, so welcome back to your favorite inorganic tutor YouTube channel once again. Today is another episode and we want to look at how we can differentiate this function, the second derivative of this particular function. You know how to differentiate the first time, the second time. So that's what we are in here for. Right, so this right here, before we can tackle this particular problem, we have to adjust the function. So in so doing, we have to introduce the natural log to both sides. Right, so when we do that, we have ln y is equal to ln into e power m sine inverse of x right here, so that we can drop this exponent and then we can work. So we have ln y is equal to m sine inverse of x ln e right here. But we know that ln e is equal to 1, right? So we say that ln y is equal to m right here sine inverse of x, because we know that ln e is 1, so whatever happens to it, the function remains like that. Now we have this right here. We can now go ahead and differentiate for the first time and then the second time. So let's start the first time. So you know how to differentiate this right here. So differential of this is going to be 1 over y, then the differential of the inner function should be equal to, this is two functions multiplying, so we are going to apply the product rule. This is a constant, so when you differentiate, it will be 0. 0 times anything is 0, so we don't mind the first part. Differentiate the second part and maintain the first one. So now we are differentiating sine inverse of x, and we know the differential of sine inverse of x as 1 over square root of, have you forgotten? It's going to be 1 minus s squared. Right, so this right here, we have y prime over y is equal to m over square root of 1 minus s squared. Very simple. So let's cross multiply so that we can have what we want. So we have right here y prime, this goes here, right? So we have y prime into square root of 1 minus s squared, and that should be equal to my, right? So now we have the first derivative. We need the second derivative. So what do we do? Let's square root, or let's square both sides so that we avoid the square root sign in there, so that our workings won't be a problem. Right, so we square both sides and we have, so let's try to use the subscript differentiation, right? Using the subscript differentiation, so that when we square both sides, we can have the square here, then 1 minus s squared should be equal to m squared y squared, right? So now this is our first derivative. We have to go ahead and find the second derivative, because that is what we are interested in. And this right here is a function, this too is a function, so two functions multiplying, we have to apply the product rule. So let's go differentiate. This is going to be 2y1 y2, then you maintain the second function plus maintain the first function y1 squared, then you differentiate the second function, and that is minus 2x. We are done with the left side, the left hand side, so we go to the right hand side. We may differentiate this, and that is 0, and 0 times anything is 0, right? So we have 0y squared plus Maintain the first term, m squared, then differentiate the y squared, right? And that is equal to 2y1 y. So now let's simplify. This is the result for the second derivative of this particular function, but let's simplify. So when you simplify this, we are going to have 2y1 y2 into 1 minus x squared plus minus 2x y1 squared. And that is equal to, this is right here is 0. So we have 2y1 ym squared. So now we can see that 2y1 is common to all the items. So we divide through by 2y1. So that is going to be 2y1, 2y1, and 2y1. Right? So this, we are going to have y2 into 1 minus s squared minus xy1 should be equal to, we have ym squared. Right. So this is our second derivative to this particular function. This is the first, this is the first, this is the second, because we were asked to find the second derivative of this particular function, and this is right here. Thank you very much for watching. I really appreciate your time. Please don't forget to press on the notification bell, and I'll give you more updates on calculus. Bye.